this lecture, we focus our attention on sizing the suction line and address issues arising in the suction line. During operation, the suction line carries cool refrigerant vapor containing droplets of compressor oil. Typically, whenever the compressor is on part load, the gas velocity at the evaporator outlet may not be enough to take the oil back to the compressor. To resolve this situation, an oil trap is connected at the exit of the evaporator. During operation, the oil collects and gets pooled in the trap. The reduced pipe diameter at the trap exit increases the velocity of the gas, which now picks up the oil, whereupon the vapor and oil are returned to the compressor. A typical view of a suction line riser when the compressor is above the evaporator is shown on this slide. Notice the reduced diameter riser pipe. Notice also the sloping of the horizontal sections to enable oil flow at low refrigerant pressure. When an evaporator is located above or at the same level as the compressor, the suction line must rise to the top of the evaporator as shown on this slide. This helps prevent refrigerant liquid from migrating to the compressor, called slugging, especially during the off cycle. Double suction risers can be used where the compressor is expected to operate at extremely low part loads, whereupon the gas pressure is likely to be very low at the evaporator outlet. At full capacity, the refrigerant passes through both risers with enough velocity to move the oil. At minimum capacity, oil in the riser fills the trap, and once the trap is full, refrigerant vapor carrying oil flows through the smaller diameter riser. In the next few slides, we undertake the sizing of the suction line of a simple DX system example. In this example, the refrigerant used is R22. The system capacity is 10 tons and it is an air-cooled system. The suction pipeline runs horizontally for 40 feet and vertically for 20 feet and comprises of 4 elbows. As regards the indoor coil, the on-coil air temperature is 70 degrees Fahrenheit, while the off-coil air temperature is 50 degrees Fahrenheit. As regards the outdoor coil, the ambient air is at 90 degrees Fahrenheit, while the air leaving the condenser is at 100 degrees Fahrenheit. The estimated value of SST, saturated suction temperature, is 40 degrees F, while the estimated value of SDT, the saturated discharge temperature, is 120 degrees Fahrenheit. It is recommended that the designed cooling coil capacity of 10 tons be multiplied with the R22 suction gas velocity correction factor. This factor can be picked off from table 4.17 of ISHRAE HVAC Databook 2017 and results in a tonnage of 10.8. The recommended pipe size is picked off from the R22 refrigerant piping guide. While the pipe length is 60 feet, we will assume an equivalent pipe length of 50% more, that is 90 feet. Carefully go over the slide to see how we arrive at a suitable pipe size of 1 and 5/8 inch. In the next few slides, we will verify that this is indeed an acceptable size. To know the equivalent pipe length of the 4 elbows, we refer to ISHRAE Databook Table 4.2. For the selected pipe size of 1 and 5/8 inch, the equivalent length per elbow is 4 feet. As shown on this slide, the total equivalent pipe length works out to 76 feet. From the Freon 22 chart shown on this slide, we estimate the pressure drop in the suction line to be 1.064 psi. On this slide, it is shown that the 1.064 psi pressure drop translates to a saturation temperature drop of 0.71 degrees Fahrenheit, which is acceptable. On this slide, we estimate the gas velocity to be 1800 feet per minute, which is adequate to carry the oil along with R22 back to the compressor. In the next lecture, we will learn how to size the liquid line. Thanks for watching.